Yeah, hi everyone. I hope everyone is good. Uh, myself, Dr. V. Ganesh Kumar, Assistant Professor working in Mathematics Department at VNR VJET. So today I'm here to discuss about the concept called calculus. Generally, the simple motivation to do calculus because we observed, as per my experience, we observed most of the people are students who come from the intermediate to engineering, so they feel difficult level at the calculus, and most of the people, of course, I have seen they neglect or they take this topic as a choice. Okay, so in order to remove that assumption, I can say assumption of those people, so I would like to give few simple applications of calculus where we can use mostly the calculus in our real life, day to day life. Okay, so that's why I given the title as calculus the motivation. Okay, right, let us go to the concept. So as all of us know, calculus having basically two categories. One is differential calculus and another one is integral calculus. Okay, so differential calculus is the change, it deals with the change, and integral calculus deals with the accumulation. Okay, so I can say change, change means rate of change, I can say rate of change. Okay, rate of change, so it can be changed with respect to any variable. So then in order to calculate that change, we use differentiation. That is the main objective of differentiation. What we see, if there is no change, as we say derivative of constant is zero, that means there is no change with respect to any variable, we say derivative of constant is zero. Okay, if there is a change, that means it is not constant but it depends on some value. Like generally we say ds by dt. As you know, speed is depending on the our distance and with respect to time. Okay, that you might have already gone through it at intermediate level. Okay, I'm not going to discuss that much here. And coming to another second one, integral calculus. So as you know, integral calculus is cumulative. Okay, cumulative or accumulation. Okay, it is a cumulative study, accumulation of the things. So from initial time to up to this much time, what is the cumulative probability, maybe, or cumulative action, maybe, or cumulative amount also we can say, that deals with the integral calculus. Okay, so how we use this in day to day life, I am just posing few questions here for you in the next slide. Like I think first question is, do you have mobile? Okay, yes, everybody, almost 90% of the people will have mobile. Okay, right. Okay, if you have mobile, do you charge it? Yes, of course, the answer is definitely daily, twice or thrice nowadays. Earlier it was once, but nowadays it is twice or thrice. Okay, if these two are yes answers, then we have two more questions here. Does a battery charge at constant rate? The question is, does your battery of your phone charge constant rate? If not, why does your phone charge fast from 0 to 50% but slow after 80? Okay, I hope you might have observed it is, you might have observed, but we see daily in life, whenever we wake up we see all these things. Okay, definitely we'll go for charging. So but have you observed these two questions? Have you answered any time? Okay, now let me answer now these two questions. Okay, doing, utilizing, differentiation, of course. Okay, right. Coming to the mathematics behind this charge. Okay, generally charge is denoted by q. Okay, you can see here the equation. It is a model or mathematical model, I can say, where charge is expressed in terms of time t. Okay, so you can observe here the time t is small t is the time. Okay, I have already written that, you can see that. What is q of t? I have written q of t because q is a charge which depends on time t. Okay, according to time it varies. Okay, so charge, maybe mobile charge, any battery, consider any battery. And q maximum, how much charge is required? Generally we go for 100% most of the times. And rc is the constant, it related to the circuits. Okay, So what interpretation is, what I am taking here interpretation is at t equal to 0. If you see at t equal to 0 in the equation, what I have taken q of t, if you observe that this part e power minus 0 is 1. So when e power 0 is 1, total charge will be 0. 1 minus 1. Okay, that means at time t I'm taking charge is 0, your mobile having charge 0. At time infinite, I mean increasing, then e power minus t decreases to 0, then you will get a q maximum. So this is the basic maths behind the equation here. So now since it depends on t, it changes time t, so I can differentiate, that is called I, current, charging current. So that I is nothing but dq by dt, as we know most of the times. So dq by dt gives I, which is a current and which is the derivative of charge. Okay, so that is given by differentiation of the equation. I can say if this is equation 1, so differentiating it with respect to t, so equation 2 will be given by or represented by the current I. Okay, I of t. So here I have come with the equations directly. I don't want to prolong this time duration for the video, so I have written already, just explaining the terms. Okay, so q dq by dt will become equation 2. Now if you observe current and charge, they are rational here. So now if you observe dq by dt, again you want to find out the current, for this you can apply. So that I can see here, for example, suppose you are required maximum charge as 100 units, which we say 100% most of the times, and let me assume the constant as 2. That constant will remind you how to charge, how much time to charge, it depends on. For this example I'm just assuming that rc equal to 2. Now if we apply these two conditions in our equation 2, at t equal to 0, my current, okay, my current will be 50. So that means it is fast charging. Okay, but if t equal to 2, as you can observe, t increasing, I value at 2 is 18.4. So it is comparatively earlier it decreasing. Okay, and at t equal to 6, I of 6 is 2.5. So as t increases, our current is becoming decreasing. Okay, decreasing. Okay, small, I can say small. So why it is happening? Now the answer is, for the first question, does it charge constantly? No, most batteries do not charge a constant rate. Okay, it is not a constant rate. So since it is not a constant rate, it changes with the time, so charging rate decreases over the time. That also you can observe. So we know that already. When it comes to 80 or 90, it will take much time, but when it is like 20 10, it will come less time, it will take less time, it will charge faster. Okay, so everything we know, every time we say statements, but every statement in background it will have a mathematics and basically that calculus. Okay, so change itself says calculus. So that calculus will be helpful to analyze any motion or any change in anything. Okay, so since we most of us go through this every morning, every day morning, I have taken this example. Okay, but anyway, what I can say as a statement is, at the beginning battery voltage is low because of less charging, so current flows easily. That's happening actually. How that equation is framed is because of these physical properties of that current and charge. Okay, so that's why it is fast charging. So as charge is increasing, voltage increases and opposite increases, so charging slows down. Okay, so I can say near full charge, current becomes very small. So almost stops. Okay, so that is the example one which I wanted to explain you. What behind that calculus is simple. Calculus is not a big one. So you think that derivative is a big one, but derivative is the rate of change of anything, any variable. Okay, if it is, now I am taking charge here, it can be for speed, it can be for velocity, anything. Okay, right. Anyway, let me go for another example. Second example, like most of us we see, after putting charge we'll go for bath to there the washroom, then we'll see there tap, okay, water, okay, fill the tank. So I want to explain this with integration idea. Okay, it is a my motivation to get into integration idea. Okay, so my main objective is to amount of water. Okay, amount of water after some time, how much amount of water will be there in the tank or bucket. Okay, so if suppose there are two ways. One thing is, if constant flow, if water is filled constantly, okay, then how much water will be there after 5 minutes. Otherwise sometimes we play, okay, like if tap starts slowly, if tap starts slowly and then speeds up, okay, then what will be the difference between the total water in this case and comparatively first case constant flow. So these two things we need to answer mathematically. See, most of us we answer, but we don't have a proof for that. So if I say there is a mathematical proof behind it, everybody believes it. Okay, so let me answer now. Again, there is a mathematics here. Simple integration. I don't want to go for bigger one. Simple integration. Okay, if suppose that is not constantly, so r of t is the rate of flow. Suppose flow rate of flow, how it is flowing. Okay, then he is asking after 5 minutes. So since it is asked 5 minutes, I will take from initial time to after 5 minutes. Okay, this is 5 minutes. Then integrating that cumulative water amount will be cumulative. Integrating that, we will get the required amount of water. But again, as I said, there are two cases. If r of t is constant, that is, it is constantly filling. Okay, no change in the flow, no change in the flow, then I can say r of t will become constant. Whenever r of t become constant, suppose I am saying it as 10, suppose I am saying it as 10, then after 5 minutes how much it will be? 50 liters. Amount of water will be 50 minutes. Okay, you can observe that r of t equal to 10. So integrating this, integration of 10 dt will be 10 into 5 minus 0. 10 into 5 minus 0. Okay, so which will become 50 liters. The second case, this is important. So there we don't involve any derivative now. Now second case is because flow changes. Okay, started slowly and then increases, maybe due to pressure or maybe you are playing with the tap, so it increases flow rate. How it is increases, that's what to be assumed. Okay, suppose it increases with the time. Okay, you can observe here I have written r of t equal to 2t. Suppose this rate of flow increases with the time 2t. Maybe if time 1 unit changes in time is changing the 2 units of that flow, then I can say it is r of t equal to 2t. Okay, if suppose it depends on time, again if I want to know the amount of water after 5 minutes, again what we do is we use integration. Okay, so integration is integration of r of t dt, where r of t is 2t. So you know, basically integration of t power n dt is t power n plus 1 by n plus 1. So using this basic formula, so we can find here t square by 2, and we're applying the limits, lower limit or initial time, and exactly what you need, at what time you need, that is 5 I have taken for example. So you will have a 25 liters. Now see, if you observe this, first case with the constant flow, we have 50 liters. Second case with the rate of change, with the flow rate change, increasing flow rate, we have 25 liters. Then what can be the our conclusion about it is, so flow rate increases, but it increases to t. So but comparatively constant flow, high constant flow, it will be less than the constant. Okay, because rate changes maybe 2t, sometimes if it is more than t, more than 10 times it will be more, but comparatively 2t, this rate of change, we can assume that, or we can conclude that here this will be less amount of water compared to the first case constant flow. Okay, but my intention is to hear just how integration is useful in our daily life. Okay, we don't use, okay, we'll say this much amount, but most of the researchers or most of the people will ask why. Okay, how you can say this? So to prove that, or to evidence it, to evidence to our statement, we required mathematics. Okay, so that mathematics most of the times, because you observe most things are changes, things changes, there is no constant in the things, but constant in changes is there, but most of the things changes. So that that change if you want to calculate, so calculus, change. If you want to calculate, use calculus. But if you are not changing and if without knowing calculus, that means you are not changing or you are not discussing about the changing, that means you stop. You are stopped. So I hope you should not stop. Everyone should change, and that change to be analyzed maybe within us or maybe within the fluid or maybe within the body or whatever it is, change is to be analyzed. But without knowing mathematics behind it, you may not come to the conclusion. Okay, right. Other than that, just list out a few applications of calculus. Of course, all these you can see in your what we call AI. Motion in everyday travel. So motion is the change. So if you want to change like speed of the vehicle, okay, speed of the body, speed of an objective, speed of a fluid particle, so that speed or change will be, we generally call it as speedometers. Okay, navigation systems, all those are depending on the calculus. And of course economics, nowadays most of the people involving it. So economics, so what we require is profit. So how to calculate profit? So that is called optimization problem. Optimization means again derivatives, calculus, okay, differentiating and making it zero, right? Weather prediction, of course, prediction, it is also changing continuously. Are you able to predict now? No, but the people are predicting, some people continuous change with what? With using calculus. Okay, so more also medicine, drug dosage depends on rate of absorption. So without knowing absorption of body, you cannot refer a drug to the people. Okay, that is also important, right? As per computer graphics, video games, so how object moves, from which side to move, or one, many video games you can see that the optimization moves will be calculated by calculus. Okay, those object move as per the calculus. Of course, most of the times you might have seen already Newton's law of cooling, cooking or cooling. If you want to take the cup of tea, how it decreases, temperature of that tea decreases with the time, that will be done by calculus again. Okay, so these are the most, everywhere I can say everywhere calculus is used, but simple few applications I have mentioned here, but don't confine to that. But in order to analyze our daily life, calculus is mandatory. So my intent to just motivate you to learn calculus here. My main intention to motivate you learn calculus, and calculus is everywhere. Okay, don't skip. Maybe you might have skipped it for the intermediate, but here when you enter into engineering, please don't try to skip it. Okay, you should involve in it, you should carry it, and you should be able to analyze it, okay, and evaluate it. Okay, so of course you can redefine it later. Okay, so I hope you understood. This simple video will make you little understanding about calculus or importance of calculus. Okay, so thank you everyone. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.